Class 12 CBSE Relations and Functions. Exercise 1.1. First heading, determine whether each of the following relations are reflexive, symmetric and transitive. Relation is given to us. We have to see whether this is reflexive, symmetric and transitive. We have to check all the three cases: reflexive, symmetric and transitive. So the first question, relation R in the set A is equal to 1, 2, 3 up to 14 defined as R is equals to xy such that 3x minus y is equals to 0. So one set and a relation in the set builder form is given. Let us check whether this is reflexive, symmetric and transitive. Solution. Let us first write down the given set. A is equal to 1, 2, 3, 13, 14. They have given a finite set to us. Relation R is equal to x, y such that 3x minus y is equals to 0. So they have given this in the set builder form. Now let us decode this and write all the elements of R. All the elements of R. We can only write the elements of R by using this property. So let us write this property here. 3x minus y is equals to 0. This implies y is equals to 3x. Let us give the value x, y and the element x comma y. So if you give the input x is equals to 1, all these inputs are from this set. So you can give 1 here. So if you give 1, the output is going to become 3 times 1, which is 3. So the first element is 1, 3. Now give x is equal to 2. So 3 into 2 is equals to 6. So therefore the element is 2, 6. Now 3, you get 9, which is 3, 9. 4, 3 times 4 is 12. The element is 4, 12. Suppose if you give 5, 3 times 5 is 15. You will get 5, 15. We cannot use this because this 15 does not belong to A. So both x and y should belong to A. Only such elements we can write here. So therefore 5, 15 we cannot write. So what are the elements we have got here is 1, 3, 2, 6, 3, 9, 4, 12. So we have written all the elements of the relation R. Now this will help us to check whether it is reflexive. So the first thing is check if R is reflexive. Okay. So what is the definition of reflexive here? For a relation to be reflexive, if A comma A belongs to R for all A belongs to the given set. So A must be related to itself. If this condition satisfies, we call it as reflexive. We have to get the same elements. The element is related to itself. See whether there is any element related to itself. 1 is not related to 1, 2 is not related to 2, 3 is not related to 3, nor 4 is not related to 4. So none of the elements are related to itself. So here 1, 1 does not belongs to R, 2, 2 does not belongs to R, 14 to 14 does not belongs to R. So therefore we clearly say that R is not reflexive relation. Next, let us check if R is symmetric. So let us see what is the symmetric means. Symmetric stands if A, B belongs to R implies its mirror image BA must also belong to R. So if A is related to B, B is also related to A. If this condition satisfies, we call this relation R as symmetric. So let us check whether this R is symmetric or not. So let us take one element. Here 1, 3 belongs to R. But 3, 1 does not belong to R. 2, 6 belongs to R. But 6, 2 does not belong to R. So we don't need to prove for all the cases. Even if one case fails, we can come to the conclusion that R is not symmetric relation. Now let us check if R is transitive. So what is the main condition for a relation to be transitive? If AB belongs to R, BC, third element, another element also belongs to R, this implies AC belongs to R. We say that the given R is transitive, right? A is related to B, B is related to C. If we also find A is related to C, then we say the given relation is transitive. So let us check whether this relation is transitive. So let us take one element. Here 1, 3 belongs to R. 3, 9, another element also belongs to R, but 1, 9 does not belong to R, right? So what you can conclude here, that R is not transitive relation. So we have checked for all the three cases, reflexive, symmetric and transitive. So what is the final conclusion? The given relation R, that is all the ordered pairs such that 3x minus y is equals to 0 is neither reflexive, symmetric nor transitive. With the same first heading, we will solve another question.